Have you ever heard of one of the world's most expensive vegetables, grown entirely in darkness, yet consumed by the hundreds of thousands of tons every year? Endive, a mysterious gem in the world of vegetables, lies at the heart of a multi-billion-dollar leafy green industry. Its strange journey begins under the sun-drenched fields, where chicory seeds are sown and nurtured until they grow into plump, earthy roots. But the real magic begins when these muddy chicory roots enter the factory. In absolute darkness, delicate endive buds silently emerge, developing their signature mild sweetness and pearly white elegance that has captivated millions of culinary enthusiasts. Today, join Agriculture Insight as we uncover why this vegetable is known as the gem of the dark in European cuisine. Everything will be revealed in this video. Outside of Europe and parts of North America, endive remains a mystery to many, not because of its flavor, but because of its incredibly complex cultivation process. Unlike most leafy greens, endive is essentially reborn twice. First, grown as chicory roots in open fields, then forced to sprout pale ivory buds in complete darkness under tightly controlled conditions. This intricate process is exactly why endive can cost 5 to 10 times more than typical salad greens. Part of endive's allure also lies in its name. Why don't people simply call it a chicory bud? The answer traces back to a fortunate accident in Belgium in the 1800s, when a farmer named Jan Lammers was storing chicory roots in his cellar for the winter. The term endive refers to something that appears at the very end, a hidden beauty that only reveals itself in the final stage of growth. Have you ever heard of or tasted this mysterious vegetable? If so, share your experience in the comments below. In Belgium, the birthplace of endive, around 110,000 tons are harvested each year, accounting for 30% of global production and generating hundreds of millions of euros. France and the Netherlands are also major producers, utilizing hydroponic systems and advanced environmental control technologies to grow it at scale. But why is growing in darkness so essential? Because without light, the plant doesn't produce chlorophyll, allowing the endive to retain its creamy white color, mild bitterness, and crisp, juicy texture, all defining features that give it its premium status. If exposed to light, the buds would simply grow into regular chicory plants. All wonders begin somewhere. For these gems of the dark, the journey doesn't start in the shadows. It begins in the light, in the sunny fields where chicory is sown and nurtured just like any other vegetable. The first stage in the production of endive begins with preparing the soil for growing chicory roots, the very foundation that determines the quality of the final buds. The ideal soil is a sandy loam with a neutral pH, promoting rapid root development and maximum energy storage for the later forcing phase. In early spring, chicory seeds are sown directly into the soil at a depth of about 1.5 to 2 centimeters using mass seeding machines. These machines not only drop the seeds in neat, parallel rows, but also gently compress the soil above them to retain moisture and improve germination rates. After about 120 to 150 days since the tiny seeds first broke through the soil, the chicory field has transformed into a lush green carpet, marking the moment when the hidden roots beneath the soft earth are finally ready for harvest. Depending on regional climate conditions, the ideal harvest period typically falls between September and November. As the machine moves through the chicory rows, the first component to engage with the plant is the leaf cutting unit. Rotating blades or horizontal cutters slice off the leafy tops of the chicory plant, exposing the crown of the root and clearing space for the following mechanisms to work with precision. Immediately after, the root digging mechanism goes into action. two V-shaped steel blades positioned beneath the machine gently slide into the soil on either side of the chicory base, slicing through the ground and creating a path for the lifting system. The cutting depth can be adjusted between 25 and 35 centimeters to match the average root length of each harvest batch. At first glance, the Chicory Harvester might resemble a carrot pulling machine. However, it's far more refined, featuring soft grip clamps, a vertical lifting system, and an advanced soil cleaning unit. These design enhancements are crucial to preserving the long, delicate roots intact, minimizing damage, and ensuring they retain the ability to sprout again during the forcing phase. Once lifted from the ground, the chicory roots are gently transferred onto a rubber conveyor belt, equipped with padded cleats to minimize impact. A modern harvester can process between 8 to 15 tons of chicory roots per hour, depending on planting density and soil conditions, with damage rates typically kept below 2%. But this is only half the journey. As the transport trucks loaded with chicory roots leave the fields, they head toward the most critical and unusual phase of endive production, the forcing stage in complete darkness. It's here that these seemingly rugged roots quietly transform into elegant, high-value endive buds, delicate treasures born not in sunlight but in the shadows. Upon arrival at the factory, the dump trucks or trailers loaded with chicory roots are sorted and processed according to the current intake capacity of the production line. Chicory roots harvested early in September often haven't reached optimal size or maturity. These are typically set aside and stored in cold chambers for an extended period. It's crucial that the temperature remains stable between 0 and 1 degrees Celsius to ensure the roots enter a full dormancy, preventing premature sprouting while preserving the internal energy reserves needed for the endive forcing phase later on. Chicory roots, harvested between October and November, are typically mature enough to proceed directly to the forcing stage in the darkroom, the beginning of their transformation into ivory-white endive buds, crisp, delicate, and among the most premium vegetables in the world. At the factory, entire truck beds are lifted using hydraulic systems, allowing tons of chicory roots to slide steadily into a large receiving chute. This chute feeds directly into the main intake hopper of the preliminary cleaning line. Just beneath the hopper, the primary conveyor system begins operating, guiding the flow of chicory roots onto a roller belt equipped with rotating rubber brushes and mechanical rakes. These components work together to remove any remaining leaf stems, clumps of dry soil, lateral roots, and coarse debris. Next, the roots pass over rollers with narrow gaps or a rotating mesh surface, allowing fine soil, small stones, and organic fragments to fall through. This phase isn't just about cleaning, it's a crucial preparation step that readies the chicory roots for their second life cycle. After the initial cleaning phase removes most of the soil and debris, the chicory roots move on to a deep washing conveyor. Here they pass through high-pressure water jets positioned along the belt, or are placed into a rotating drum washer for thorough rinsing. Interestingly, from an agricultural processing standpoint, some factories skip this washing step entirely, especially when the roots are already sufficiently clean and will be stored only briefly. After washing, the chicory roots are sent to the sorting and quality control area. Here, workers manually remove any roots that are broken, moldy, rotten, or incorrectly sized. Only roots that meet strict criteria, straight, long, undamaged, and of sufficient size, are kept for the next phase, bud forcing. Meanwhile, the growing racks equipped with trays, each divided into square cells sized to fit individual chicory roots, are first filled with cool water. This step helps establish a stable, humid, and temperature-controlled environment ideal for bud forcing. Once the trays are in place and filled, workers carefully insert each chicory root into a cell with speed and precision, ensuring the base of the root makes proper contact with the water surface. The roots are spaced evenly to avoid overcrowding, creating optimal conditions for uniform sprouting and producing high-quality endive buds. At last, after all the meticulous preparation, the strange journey of the chicory root reaches its most awaited chapter, the darkroom forcing stage, where the real magic begins. The first key to success is creating an environment of total darkness. Only in the absence of light can the plant's natural biology be deliberately redirected and controlled, steering its growth in a completely new direction. To achieve this, the environment is carefully controlled. Temperature is kept steady between 12 to 16 degrees. Air humidity is maintained at 90 to 95%, and oxygen levels are adjusted to slow down respiration and limit natural oxidation. As a result, the buds grow slowly but consistently, with reduced risk of rotting and a uniform, elegant shape, each one a flawless product of darkness and precision. Beneath each tray is a recirculating hydroponic system that delivers water and nutrients from the bottom up. This ensures the root bases remain consistently moist without water pooling on the buds, reducing the risk of fungal infections while encouraging the sprouts to grow upright, thick, and uniformly shaped. Inside the darkroom, the space is organized into multi-tiered shelving racks, each level holding hundreds of trays. This vertical layout allows thousands of chicory roots to be cultivated simultaneously in a closed-loop system optimized for mass production. The forcing process typically lasts between 20 and 25 days, during which the growth of the buds is continuously monitored by a network of sensors connected to a central control system. This ensures precise regulation of environmental conditions, allowing the sprouts to develop at a steady, optimal pace. If you want to become a classic-style farmer, try growing endive using the traditional soil forcing method. Instead of investing in complex hydroponic systems, this approach allows chicory roots to be planted directly into soil beds inside a dark room. The entire bed is covered with black plastic sheets to retain moisture, block out light, and maintain stable temperatures, creating ideal conditions for the buds to grow. Chicory grown this way often produces endives with a richer flavor, denser texture, and thicker leaves compared to hydroponic cultivation. Although it requires more space and yields less, this traditional model is still practiced on many farms across Europe, especially in Belgium, the birthplace of endive. At the end of all the patience and meticulous labor comes the most rewarding moment, harvest time. When the endive buds reach 12 to 15 centimeters in length with uniformly pointed tips, tightly wrapped leaves, and no gaps for light to enter, they are considered perfectly mature, forming what many call pearls of the dark, known for their crisp texture, delicate sweetness, and the near-complete absence of chicory's natural bitterness. In modern facilities, the harvest is assisted by rotary disc cutters, machines hailed as essential tools in the final stage of production. Their continuous and precise operation can boost productivity by 3 to 5 times compared to manual cutting, while significantly reducing damage caused by improper handling. The machine features a large rotating disc divided into multiple compartments, each designed to securely hold the chicory root horizontally. The entire operation runs continuously and smoothly, with each rotation typically processing 4 to 6 roots, depending on the machine's configuration. Once separated, the endive buds drop gently into a collection chute and are transferred to a sorting conveyor, where workers inspect and remove any buds with loose leaves, deformities, or imperfections, ensuring that only flawless specimens continue on to packaging. After harvesting, the old and excess endive leaves are collected separately. Rich in fiber and nutrients, they're often composted into organic fertilizer or repurposed as livestock feed for animals like cows, goats, and rabbits. The spent chicory roots, having completed their role in sprouting, are also separated and sent for biological processing or converted into biofuel. This allows for the recovery and reuse of up to 95 to 100% of the plant's biomass. It's a prime example of the closed-loop cycle in modern agriculture, where every part of the plant is utilized, not only to produce premium endive, but also to support environmental protection and sustainable development. To save time and ensure absolute hygiene, modern farms use automated robots to wash the growing trays after each endive cycle. These systems use high-pressure water jets and rotating brushes to thoroughly clean every corner, removing soil, root debris, and any remaining microorganisms. After sorting, the premium-grade endive buds are transferred to the packaging line in a chilled environment. Depending on the target market, the buds may be packed in breathable mesh bags, plastic trays with shrink wrap, or vacuum-sealed packaging, extending shelf life up to 2 to 3 weeks while preserving freshness and structure. Finally, the packaged units are labeled, tagged with traceability codes, and stored in cold chambers awaiting shipment. And just like that, from a humble root grown under open skies, through a dual life journey between light and shadow, the endive bud is born, a symbol of refinement, precision, and sustainability in modern European agriculture. Imagine standing in the heart of an endless sea of orange trees, stretching beyond the horizon. Welcome to São Paulo, Brazil. Brazil grows more oranges than any other country, over 17 million tons every year, nearly a third of the world's supply. But when it comes to turning those oranges into juice, the United States holds the crown, thanks to Tropicana. Today, Tropicana orange juice is enjoyed by millions around the world, with over 1 billion bottles produced each year, all thanks to a secret recipe that has been carefully guarded for decades, which we're about to uncover in this video. Bursting with vitamin C, orange juice contains twice as much as apple juice and nearly 3 times more than grape juice, turning your morning glass into a daily dose of sunshine and health. Like every great story, this one begins at the source, with the season's first ripe oranges, gently hand-picked from the orchard, revealing the very first secret in this magical process. Every year in November, the endless orange groves enter their most vibrant and bustling harvest season. Oranges must reach just the right level of ripeness, with firm, plump skins and a bright orange hue, before they can be picked to ensure the highest quality. At large-scale farms, harvesting machines operate in a highly systematic way. Soft brushes or vibrating rods move along each row of trees, calibrated to generate just the right amount of shaking, depending on the thickness of the branches and the ripeness of the fruit. Beneath the trees, a synchronized conveyor system quickly and continuously gathers the falling oranges, minimizing bruising and ensuring no ripe fruit is left behind. Meanwhile, in orchards where trees grow more naturally without neat rows, tree shaking machines are the more common choice. The mechanical arms of these machines clamp onto the tree trunks and create powerful vibrations, causing all the ripe oranges to fall onto large tarps spread out beneath the trees. These modern systems can harvest up to 100 tons of oranges per day with remarkable speed and efficiency, especially ideal for orchards that are neatly pruned and organized in straight rows. However, as the saying goes, haste makes waste. Harvesting quickly with machines can damage the peel and the tree itself, while unripe oranges also get caught in the process. Perhaps even the orange trees wish for gentler treatment. That's why, on smaller farms, hand-picking remains the preferred method. Workers use specialized clippers to carefully harvest each orange, checking its ripeness right there in the orchard before gently placing it into baskets or mesh crates to avoid bruising. In the US, the job of picking oranges, rain or shine, is mostly done by immigrant laborers, earning about $1 per box. Strange as it may sound, these days it seems that an orange has an easier time immigrating to America than people from Mexico and many other countries. Once the baskets are full, the oranges are loaded onto small trucks and transported to a central storage area. And now, let's follow these oranges as they enter a world of high-tech processing. Inside the orange juice factory, where secrets that have been closely guarded for decades are finally about to be revealed. As soon as the crates filled with plump, ripe oranges arrive at the factory, they're moved onto a conveyor belt fitted with rotating rollers. This roller system allows workers to examine each orange from multiple angles, identifying any that are bruised, rotten, or below standard size. Oranges that don't meet the requirements are immediately removed to ensure only high-quality fruit advances to the next stages of processing. Once the oranges pass quality control, they proceed to the cleaning area. Here, they're placed into large water tanks equipped with air bubble systems and sanitizing solutions that remove dust, pesticide residue, and any other impurities clinging to the peel. After this initial soak, the oranges roll through high-pressure spray nozzles for a final rinse, ensuring the surface is perfectly clean before entering the processing line. They are then moved to the drying conveyor. Powerful fans, working alongside rollers covered with soft bristles or special brushes, gently dry the oranges without damaging their delicate outer skin. In another part of the process, a modern factory setup will leave you amazed with its state-of-the-art machinery and impressive efficiency. Next comes sorting, a step that might seem simple, but is actually one of the most crucial links in the chain of producing a high-quality bottle of Tropicana orange juice. Only oranges that are perfectly ripe, full of juice, and have a flawless sweet-to-tart ratio are selected. A modern conveyor system equipped with sensors and automated cameras handles the sorting process based on size, color, and surface quality. The oranges first pass over adjustable slots that separate them by size. Smaller than standard fruit falls to a lower level for separate processing, while larger ones continue down the main line. In addition to the automated systems, trained workers are positioned along the conveyor to perform a final inspection, catching any flawed oranges the machines might miss. After this stage, the sorted fruit is directed to the appropriate processing or packaging area according to its quality. This meticulous sorting process ensures that only the best oranges make it into every bottle of juice. By combining advanced technology with human expertise, the factory maintains consistent flavor, color, and quality in every batch. The mixture of orange peel, sugar, and lemon juice is cooked in steam kettles or large copper pots at a temperature of around 104 and 108 degrees Celsius until it reaches the ideal thick, jam-like consistency. Once the ideal consistency is reached, the marmalade is poured into glass jars or plastic containers using an automated filling system on the production line. This filling process takes place in a sterile environment to ensure each container is filled with the exact amount of marmalade and remains uncontaminated. Lids are sealed, either screwed or pressed on, and labeled with full product details, including ingredients and expiration date. Sensors on the conveyor verify that each label is properly aligned and undamaged. After labeling, the jars go through a final quality check before being packed into cardboard boxes, sealed, and prepared for distribution. And now we arrive at the star of the show, the process behind the creation of those world-famous bottles of fresh orange juice. Once sorted, the oranges are sent into a modern mechanical juicing system, where they are pressed whole, no slicing required. Rotary drums or high-pressure presses compress each fruit, extracting the maximum amount of juice. This closed-loop system not only maximizes juice yield but also preserves the fresh flavor and natural nutrients, ensuring top-tier quality in every drop. Once extracted and filtered, the fresh orange juice is sent through a rapid pasteurization process, typically by briefly heating it to 85 to 90 degrees Celsius, and then quickly cooling it down. After pasteurization, the juice is poured into large specialized drums, usually ranging from 180 to 200 liters in capacity, and immediately stored in cold rooms at temperatures between 0 and 4 degrees Celsius. Afterward, the juice undergoes a thorough and multi-step quality inspection process to ensure it meets the highest standards of safety, purity, and flavor. Laboratory technicians collect samples from each batch to test for microbial content, pH levels, sugar concentration, and vitamin retention. Advanced analytical equipment is used to detect any possible contaminants or inconsistencies. At the same time, trained sensory panels may evaluate the taste, aroma, and color to ensure the juice maintains its signature freshness and balance. Storing the juice in these large batches helps maintain its quality and makes it easier to handle bulk distribution or prepare for final packaging later on. The entire bottling process is conducted in a sealed, sterile environment to prevent bacterial contamination and preserve product integrity. Before filling, empty containers, typically PET plastic bottles, glass bottles, or aseptic cartons, are thoroughly cleaned and dried with sterile hot air. The juice is precisely dispensed into the containers using volumetric sensor-controlled nozzles. Immediately afterward, the bottles are sealed tightly and passed through a tunnel pasteurizer using steam or hot water, which provides an extra layer of sterilization around the bottle's mouth and cap. This not only kills any remaining microorganisms, but also stabilizes the internal pressure to prevent the bottles from deforming during storage. Once pasteurized, the bottles are quickly cooled using cold mist sprays or immersion in chilled water baths. They then continue down the production line for final quality checks. Bottles that pass inspection are labeled, packed into boxes, stacked on pallets, and transferred into refrigerated storage, ready to be shipped to markets around the world. Just one cassava root can take a life, if not properly processed. It may sound exaggerated, but the truth is that cassava contains cyanogenic glycosides, which when broken down release hydrogen cyanide, HCN, a deadly toxin that can cause death in just a matter of minutes. Despite its inherent risks, cassava is a paradoxical crop that humans have domesticated and spread across the globe since the 16th century, primarily through colonial empires, where it quickly became a staple crop and laid the foundation for a multi-billion-dollar starch industry. And from there, throughout history, cassava has time and again played the role of a silent hero, saving millions from famine across Africa, China, India, and even during the Vietnam War. That's why, in Africa, cassava is seen as a symbol of life and the unyielding will to overcome hardship. Compared to potato and sweet potato starch, cassava starch contains a higher starch content of up to 80 to 85% and stands out for its strong thickening power, high clarity, neutral taste, and low cost, making it ideal for both the food and industrial sectors. Like every legend, the journey of cassava begins with Mother Earth, where humble cuttings grow through sun, wind, and time, beginning a new life cycle for a crop that nourishes millions. In early spring, as the land welcomes its first rains after the dry season, weather conditions become ideal to begin a new cassava growing cycle. Unlike many staple crops that are grown from seeds or seedlings, cassava has a unique trait. It is propagated using stem cuttings from the previous harvest. Healthy cassava plants are carefully selected after harvest to serve as mother plants, a crucial step as the quality of the stem cuttings directly affects the sprouting rate, growth performance, and yield of the next generation. The selected stems are then trimmed into cuttings measuring 20 to 25 centimeters, each with 5 to 7 healthy buds to maximize sprouting potential. Before planting, these cuttings are often treated with antifungal solutions to prevent root rot and pest damage. Another important factor is soil preparation. The land is deeply tilled to a depth of 30 to 40 centimeters using mechanized plows, creating optimal conditions for root development and making future harvesting easier. A common planting distance of 80 by 100 centimeters provides enough underground space for tuber clusters to grow, while also ensuring compatibility with modern harvesting machinery. Today, in many specialized farming regions, cassava planting has been mechanized. Farmers use specialized cassava planters that can simultaneously create furrows, place cuttings, cover them with soil, and press the ridges, all in a single pass. Such machines can plant 1 to 2 hectares per day, significantly reducing labor and saving time. After planting, a light watering may be needed if the soil is dry. Within 7 to 10 days, the cuttings will take root and sprout, beginning their gradual transformation into full-grown plants. An interesting fact is that the long, pointed lobes of cassava leaves are sometimes mistaken for cannabis, a surprisingly common misconception in both rural and urban areas. With proper cultivation techniques, cassava plants can reach a height of 1.5 to 3 meters, with vigorous root development that leads to high yields at the end of the 8 to 10-month growing cycle. This marks the foundation for a bountiful harvest, completing a journey that began with humble stem cuttings. At large-scale cassava farms, modern machinery is brought in to streamline operations. On wide, flat fields lined with neatly arranged rows of cassava, specialized harvesters move steadily along the beds. At the front, rotating blades swiftly clear the mature stalks. Immediately behind, a set of digging blades sinks into the soil, gently lifting the entire root system and pulling out clusters of cassava tubers. As the machine completes a row, the cassava plants vanish, leaving behind loosened soil and exposed roots near the surface. Workers then step in to collect any remaining tubers by hand and place them into large baskets or sacks positioned along the rows. Once full, the sacks are hoisted onto waiting trucks at the edge of the field. The entire process is smooth and efficient. Each pass of the harvester can save hours of manual labor, dramatically increasing harvesting productivity, especially during peak seasons. In smaller farms or areas with sloped terrain, hard soil, or irregular planting patterns, cassava is still harvested by hand. Though more labor-intensive, this traditional method can still be highly effective when done correctly. In loose, well-aerated soil, farmers can uproot entire cassava plants by hand without the need for hoes or crowbars. They then use specialized knives to separate the root clusters from the stems and gather them into baskets or sacks. It's a physically demanding task that requires strength, patience, and technique, especially under scorching sun or in hardened soil. In some regions, farmers first cut the stalks, then use a digging tool to lever the root base out of the ground. Once lifted, the roots are shaken clean, separated from the cluster, and placed into containers for transport. And when the trucks are finally filled to the brim, they roll away from the fields, marking the end of a fruitful harvest season and the beginning of a new journey, as these soil-covered cassava roots are transformed into pure white starch, ready to serve the food and industrial sectors. As soon as the trucks arrive at the factory, the cassava roots are unloaded at the receiving area and temporarily stored in a holding yard. Depending on the scale and capacity of the facility, the plant can handle up to several thousand tons of fresh cassava per day. At this stage, a preliminary inspection is carried out to remove damaged, rotten, or heavily contaminated roots before entering the processing line. At this stage, the raw cassava roots are divided into two main processing streams, depending on their intended end use. One portion goes through the dry processing route, where the cassava is thinly sliced, typically to a thickness of 3 to 5 millimeters, to facilitate faster and more uniform drying. It is widely used in the animal feed industry due to its high energy value and also serves as a key input for fermentation-based industries, such as the production of bioethanol, vinegar, organic acids, and various other bio-based products. The other portion is directed toward further processing into refined cassava starch. From the storage yard, an automated conveyor system continuously feeds the selected roots into the cleaning section, marking the beginning of a fully enclosed and high-capacity processing line. From the receiving conveyor, the cassava is transferred into a continuous washing system, typically a horizontal drum washer. This machine operates by rotating while internal spiral paddles and high-pressure water jets work together to remove all soil, sand, mud, and the thin outer skin from the surface of the roots. As the drum spins, the cassava roots tumble against the rough inner surface and against each other, causing dirt and skin to peel off naturally without the use of chemicals. In industrial processing, cassava roots are not completely peeled as they are in traditional methods. Instead, they are thoroughly washed and mechanically cleaned to remove dirt and the outer skin, allowing for maximum starch retention. As a result, a certain amount of cyanogenic compounds, primarily linamarin, may still remain in the roots, especially in bitter cassava varieties. And to eliminate this natural toxin, we must now take a closer look at the critical processing steps that follow. After washing, the cassava is passed through a manual inspection stage. Here, workers remove any damaged, bruised, or diseased roots that machinery might not detect accurately. The selected cassava is then either cut into smaller pieces or left whole, depending on the requirements of the next step, grinding. At this stage, the cassava is fed into either a roller crusher or a high-speed blade grinder, where it is crushed into a pulp. This mixture consists of starch dissolved in liquid and fiber that has not yet been separated. This is a crucial step that breaks down the cellular structure of the roots, allowing for the maximum release of starch from the raw material. The pulp mixture after grinding, consisting of starch dissolved in water and undetached cassava fiber, is transferred to a centrifugal or vibrating screening system, depending on the technology used by the factory. In a centrifugal sieve, the mixture is pumped into a high-speed rotating drum covered with a fine mesh screen. The centrifugal force pushes the mixture outward toward the screen, allowing the fine starch and liquid to pass through the mesh, while cassava fibers and larger impurities are retained and discharged separately. The separated fiber doesn't go to waste. It's collected and used as rough animal feed, as it still contains a small amount of starch and beneficial fiber, making it a nutritious meal for our cows. Do you agree with these moo? The next step is dewatering. Various methods are used depending on the scale and level of automation of the factory. At medium and small-scale facilities, a filter press is commonly used. In this system, starch slurry is compressed under high pressure between thick filter plates, effectively removing most of the water from the mixture. The result is a semi-dry starch cake with a moisture content of around 40 to 45%, which is soft, white, and moldable. This semi-finished material is essential for the subsequent drying process. Although the filter press operates in cycles, it is easy to maintain, simple to operate, and well-suited for medium-capacity production lines. In large-scale industrial factories, where high output, continuous operation, and full automation are required, the dewatering process is typically upgraded to a rotary vacuum filter. This equipment uses a rotating drum combined with vacuum suction to continuously extract water from the starch slurry. As the drum rotates through the starch tank, a thin layer of starch adheres to its surface and is gradually dried by suction through a filter cloth. This is also a critical stage for removing most of the natural toxins found in cassava roots. After grinding, cyanogenic compounds are released and dissolve into the water. Through continuous steps of fiber separation, filtration, and dewatering, the majority of hydrogen cyanide is carried away with the liquid waste, significantly reducing the toxin content before the drying phase begins. During the dewatering process, a large volume of wastewater is generated from stages such as root washing, grinding, sedimentation, and filtration. This wastewater contains residual starch, organic matter, and suspended solids, which, if not properly treated, can cause serious pollution to surrounding water sources. To manage this, factories typically implement multi-stage wastewater treatment systems, including primary sedimentation, flow equalization, biological treatment, and final disinfection. Some modern facilities also incorporate biodigesters, which recover biogas from sludge, reducing emissions while generating renewable energy to power the production line. This is a key factor enabling the cassava starch industry to grow sustainably and in an environmentally friendly manner. Meanwhile, the semi-dry starch is fed into a flash dryer, where high-speed hot air rapidly evaporates the remaining moisture in just a few seconds. The heat source for this drying system typically comes from biomass burners, coal, firewood, or gas, combined with automatic temperature control systems to ensure energy efficiency and consistent product quality. The result is a fine, white cassava starch powder with a standard moisture content of less than 13%. After drying, the starch exits the flash dryer at a high temperature and must be cooled immediately to preserve its quality. A forced air cooling system is used, blowing controlled streams of cool, filtered air through the starch as it moves along the conveyor. Once cooled, the starch passes through a sieving system, typically a high-frequency vibrating screen or a roller-type disintegrator. These machines are designed to gently but thoroughly break down any remaining agglomerates formed during drying. This step ensures the starch has a fine, uniform texture, removes any oversized granules or residual impurities, and prepares it for precise and consistent packaging. Once the starch meets quality standards, it is transferred to an automatic packaging system. Depending on demand, the product is packed in 25 kilograms or 50 kilograms bags, or in jumbo bags weighing up to 1 ton, suitable for both consumer markets and industrial processing. From humble, soil-covered roots to a refined, pure white powder, through human hands and modern technology, a remarkable journey unfolds, producing starch that nourishes people, powers industries, and connects the world. But the sun-drenched desert accounts for only half of the date's exceptional quality. The other half of this sweet journey truly begins once the ripe fruits enter the factory, where the final caliber of each date is ultimately determined. Upon arrival at the factory, all dates undergo an initial inspection before entering the production line. Any batches that do not meet the required standards are either rejected or diverted for separate handling. Meanwhile, the batches that meet the standards are moved onto the processing line. First, the dates are poured onto conveyor belts and transported to the cleaning area. Here, they are submerged in large water tanks with air agitation and high-pressure water jets. This step is designed to remove dirt, sand, insects, and any other impurities clinging to the fruit's outer skin. While high-pressure washing effectively removes dirt, debris, and surface residues from the dates, it does not completely eliminate pesticide residues that may have penetrated beneath the skin. Therefore, strict control of farming practices and careful sourcing of raw materials are essential to ensure safe, high-quality products. After cleaning, the dates are transferred onto multi-lane conveyor belts, which align the fruits into neat rows to prevent overlap and minimize bruising. At the end of the conveyor, the dates pass through an array of automated inspection equipment that includes industrial cameras, multispectral scanners, and sometimes gentle pressure sensors. This advanced system can handle up to 50,000 dates per hour, equivalent to the manual output of around 1,000 workers in the same time frame, greatly optimizing productivity, reducing labor costs, and ensuring high sorting accuracy. For premium whole fruit fresh products, the sorted dates undergo one final manual inspection by staff to ensure that only the highest quality fruits make it to the next stage. Depending on the intended use, the dates are either packaged fresh as whole fruits or sent to drying chambers. Drying extends their shelf life and prepares them for further processing into value-added products. For dwarf varieties of date palms such as the Barhi cultivar, the fruits often ripen to a bright golden yellow, making them especially popular for fresh consumption. These trees are easier to care for and harvest, and their fruits are also more affordable. If dried, the dates are processed using a hot air convection system where both temperature and humidity are carefully controlled. This method reduces the moisture content to an ideal level, typically below 20%, extending shelf life while preserving the fruit's natural sweetness and soft, chewy texture. Some premium products undergo additional steps after drying. These include pitting and stuffing, with popular fillings like almonds, walnuts, or soft cheeses. Once stuffed, the dates are gently reshaped using molds to ensure a consistent appearance. But the journey isn't over yet. Before we explore the remarkable uses of date seeds and the sweet, pureed flesh, we first step into the world of modern packaging. After undergoing thorough inspection, each date is transferred into an automated portioning machine. where sensors precisely determine the required weight for each pack, ensuring consistency across all finished products. Next, the dates travel through chutes and are automatically dispensed into bags, boxes, or plastic trays, depending on the intended packaging format. A heat sealing system works in perfect sync with the portioning unit to immediately seal each package, preventing exposure to outside air and helping maintain freshness.